an object that was defined as a quasi-moon, a mini-moon that was added perhaps to the actual moon that we have. It was discovered just a couple of months ago near Earth. And this is an interesting question as to whether such an object, suddenly we see a mini-moon that is around us. Is that the monitor, installed by some interstellar visitor? We have to keep our eyes on the sky and figure things out based on data.
Harvard astrophysicist Avi Lobe has now released new imagery and observational commentary on the interstellar object known as ATLAS. On October 29, 2025, at precisely 7:47 a.m. Eastern Time, ATLAS reached Perihelion, the closest point in its orbit to our Sun. According to the data published by NASA JPL Horizons, the timing of this event was calculated with a precision margin of only a few minutes. For the field of observational astronomy, this was expected to be a defining moment, offering a rare chance to directly study an interstellar object under extreme thermal conditions. But there is a significant obstacle. At the exact moment ATLAS reached perihelion, the object was positioned directly behind the Sun from Earth's line of sight. This means no ground-based telescope and no Earth-orbiting optical instrument could directly observe it. In other words, the most critical moment of the object's journey occurred out of view, concealed by the Sun's overwhelming brightness. As Avi Lobe noted in his published remarks, we simply do not know what is happening to ATLAS during the peak of its solar heating. The object is being exposed to approximately 770 watts per square meter of solar energy, a level of heating that could severely stress a fragile, naturally formed comet. If ATLAS is held together by weak structural integrity, it is possible that it is currently fragmenting or reshaping in ways we cannot witness because of the Sun's obstruction. Lobe also pointed out a missed scientific opportunity. If Earth had been located at the orbital position it was 6 months earlier, or 6 months from now, the geometry would have allowed ATLAS to pass close enough for planetary radar imaging. In that alternate alignment, the object would have been only 54 million kilometers away from Earth, close enough for existing radar systems to map its shape directly. Multiple radar captures during its 16.2-hour rotation period could have produced high-resolution three-dimensional structure models. However, in our actual orbital position, even at the closest approach on December 19, 2025, ATLAS will still be approximately 269 million kilometers from Earth. At that range, radar reflection is too weak to resolve any usable detail. Simply put, a rare scientific opportunity arrived at the wrong time in Earth's orbit. Because of the object's documented anomalies, radio observatories worldwide are currently conducting continuous monitoring. In addition, U.S. Congresswoman Anna Paulina Luna is advocating for the release of high-resolution images captured on October 2, 2025, which have not yet been made publicly available. Researchers are listening and watching for specific signs. Any intentional course adjustments, the possible release of smaller subsidiary probes, narrowband radio transmissions, unusual thermal signatures, or the presence of non-solar illumination. So, what exactly is ATLAS? Identified as the third confirmed interstellar object, it immediately became the most unusual among them. Based on photometric estimates, ATLAS has a minimum diameter of around 5 kilometers, making it 1 million times more massive than the first interstellar visitor, Oumuamua, and roughly 1,000 times larger than 2I Borisov. For comparison, the largest human-made rocket, SpaceX Starship, is about 100 times smaller. The scale difference alone makes ATLAS exceptional. Avi Lobe assigned ATLAS a classification score of 4 on the Lobe scale, where 0 represents a definitely natural object and 10 represents a definitely technological one. This score was based on 8 major anomalies observed so far. The first anomaly is its precise orbital alignment with the ecliptic, something that should not occur randomly for an object arriving from deep interstellar space. The second anomaly is the anti-tail jet, a jet directed toward the Sun, contradicting the fundamental physics of comet behavior. This suggests a process that is not driven by sunlight, but by an internal mechanism that is not yet understood. The third anomaly concerns ATLAS's mass and velocity. In interstellar environments, larger objects typically move more slowly because they originate from gravitationally stable regions, such as planetary belts or long-settled orbital systems. Smaller fragments, by contrast, are more easily accelerated and can travel faster across stellar distances. ATLAS, however, does the opposite of what is expected. It is both massive and fast. Its estimated diameter places it among the largest interstellar objects ever detected. Yet its inbound velocity is higher than that of much smaller bodies like Oumuamua or Borisov. This specific combination of high mass and high velocity is statistically unlikely under natural gravitational mechanics. The most straightforward interpretation is that Atlas's motion may not be entirely passive. Something, either in the distant past or in the recent present, has influenced its trajectory in a way inconsistent with naturally drifting debris. This anomaly alone does not imply technology, but it does challenge conventional models of how interstellar bodies travel. The fourth anomaly is the timing of its route through the inner solar system. Atlas's path brought it into proximity with Mars, Venus, and Jupiter in a sequence that appears unusually optimized. The probability of a random interstellar object passing near 3 major planets in such well-timed intervals is extremely small, estimated to be on the order of 0.05%. Even more noteworthy is the fact that Atlas became hidden from Earth exactly at perihelion, the single most crucial moment for direct observation. While coincidence is always possible, the alignment of planetary encounters and observational concealment raises legitimate scientific curiosity. It is as if the object's path was arranged to allow possible planetary survey while minimizing the chances of real-time study from Earth. This does not prove planning or intentionality, but the configuration is unusual enough to merit serious analysis rather than dismissal. The fifth anomaly concerns Atlas's chemical composition. Spectroscopic imaging of the gaseous plume surrounding the object revealed a composition unusually rich in nickel compared to iron. The nickel-to-iron ratio is similar to what is found in certain industrial alloys produced through metallurgical refining. In natural comets, iron is normally far more common than nickel. The only known environments where nickel dominates are either in engineered materials or in extremely rare astrophysical environments, not associated with active cometary bodies. In addition, the nickel-cyanide ratio observed in Atlas's plume is orders of magnitude greater than those measured in any known comet, including 2I Borisov. This suggests that the plume may not be the result of ordinary sublimation of primitive cosmic material. Instead, it could reflect processed or altered material, which again challenges standard cometary classification. The sixth anomaly addresses the absence of water. Most comets are composed primarily of frozen water and volatile ices, often described as dirty snowballs. Typically, comets contain 80 to 90% water ice by mass, with dust and other elements making up the remaining portion. Atlas, however, contains only about 4% water. This extreme dryness is inconsistent with comets formed in cold, outer regions of star systems. Its composition is far closer to metallic asteroids or artificial structural objects than to natural comets. If Atlas originated in a region where water could not form or be retained, its other alignments and anomalies become even harder to reconcile with natural origins. The seventh anomaly involves the polarization of reflected light from Atlas's surface. Light polarization is used in astrophysics to infer surface texture and material characteristics. Atlas displayed extreme negative polarization, a property never recorded in any known comet, including 2I Borisov. This indicates that its surface reflects light in a fundamentally different way from typical icy or rocky bodies. Something about its surface structure, layering, or composition is not comparable to known natural objects. This is not simply a chemical anomaly, it is a structural one. The eighth anomaly relates to Atlas's arrival direction. Tracing its incoming vector reveals that Atlas originated from the same region of space associated with the WOW signal of 1977, the most famous unexplained narrowband radio transmission in SETI history. The directional alignment is within 9 degrees, statistically significant enough to draw scientific attention. While this does not prove a connection, the coincidence between the most anomalous interstellar object ever detected and the most anomalous radio signal ever recorded is notable. When the probabilities of all 8 anomalies are multiplied, the likelihood of Atlas being a natural object is estimated at less than 1 in 10 quadrillion. This does not confirm artificial origin, but it strongly suggests that a natural explanation may be insufficient. Scientists are currently watching for 3 definitive signatures, controlled maneuvers release, of subsidiary probes' narrowband radio transmissions.